What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at our index notations and significant figures again, but this time we're looking at super small numbers. So when we've got really long decimals with a lot of zeros at the front. The skills that we need to learn for this lesson are exactly the same as the ones that we did in the last lesson. But students really freak out because instead of using big numbers that are easy to visualize, we're talking about really small numbers. But the mathematics behind it is exactly the same, and I guarantee you're going to do this 100% correct. So the three skills are exactly the same. First, we need to identify the significant figures that are asked for in the question. Then you've got to write down times 10. Then you've got to make sure that you can count the jumps that the decimal place makes, because that is going to tell us how big or small this number actually is. Finally, we are multiplying by times 10 again, and we need the power up the top. But for this one, the powers are always going to be negative numbers because that's going to make an incredibly small number instead of a really big one. So what we need to know is that 10 to the power of -1 is equal to 0.1. So instead of becoming larger, it's becoming much smaller. And then 10 to the power of -2 is not 0.1, but 0.01. And this pattern still continues. So 10 to the power of -3 is 0.001. And this is why we can still use times 10 to the power of something as a really good baseline, because we're just adding in zeros every time. The more zeros that are added, the smaller the number. So what we've got to look at is the movement of that decimal place. So 3.1 times 10 to the -1 means that we're moving the decimal place one time. So the -1, one movement. So this decimal place goes from 3.1 to out the front. So this is just 0.31, and that's our answer. Wouldn't you guess it? 10 to the power of -2 means that we are jumping the decimal 2 positions. So this one's going to go in front of the 3.1 again, and now you've got to put in an extra 0. You've got to imagine it or physically write it in if you want to. And now we've done the 2 jumps, so my answer is 0.031. Once again, with 10 to the power of -3, we've got to do 3 jumps. So I've got to put it in once, and then twice, and once a third time, I would get to 0.0031. Again, I would highly recommend checking all of these in your calculator. It can get really confusing when we've got lots and lots of zeros before our numbers start, and it's really easy to get lost. Just typing into your calculator will give you the confidence that you've done it correct every single time. So the massive pro tip that I've got for you is please just use your calculator. Once you get your answer, type it into the calculator and see if it looks like the question. Again, the question is asking, hey, give a good approximation of this number. So if you type it into your calculator and it's nothing like what it was asked for in the question, you know you've done something wrong. So please take the time to do it, because it's an easy way to make sure you haven't made any errors. So this question here is looking for our answer to 2 significant figures. The first 2 non-zero numbers are our significant figures, so it's going to be 4.7 times 10. We can get to that immediately. The only hard thing is, what is this times 10 to the power of? Again, I want you to put a dot point either physically or in your mind in between the 4 and the 7, where we put it for our answer. All we've got to do now is take the decimal point that's in our question and count how many times to get to where we need it to be in between those 2 numbers. For this one, it's got to go 1, 2, 3, 4, 5. So my answer is 4.7 times 10 to the power of -5. And that's all you've got to do. Throw it in your calculator, see if it looks the same, but I guarantee you would have got this right. So for this one, we need the answer to 3 significant figures. So we're looking at that 8.8, and then we just have to change that 7 into an 8 because the 6 is the rounder. So now I've got 8.8 times 10, and all I need to do is move my decimal point from where it is at the moment to that in between 8.8, the first one. So this one here jumps 3 times. So the answer is 10 to the -3. That's all we've got to do. So by taking the time to really write out the first bits, we know what the significant figures are. We know it's times 10. The only skill is, hey, can you join 2 dots together and count on the way? Finally, for this one, we need 2 significant figures again. We go to our first non-zero. That is where the significant figures start. So we've got 4.0. And that 0.0 is totally fine. It's just saying this is the level of accuracy that the question wants. Again, 4.0 times 10. All we've got to do is count back and we'll get our answer. This one goes back 5 times, so it's 4.0 times 10 to the power of -5. So even though these numbers are outside of what we usually see, we're usually dealing with big whole numbers that are easy to visualize. These decimals do get a little bit confusing, but please take the time to scaffold it out with our significant figures at the front times 10, and then all you've got to do is count backwards. Thanks so much for watching this lesson, and I'll see you guys later.